What would happen if you fell into a black hole? The answer is far weirder and more terrifying than you can imagine. Stick around to find out, and if you enjoy mind-bending science, hit that like button, subscribe, and ring the notification bell so you never miss an adventure. All right, let's set the scene. You're an astronaut on a daring mission, drifting through the silent, inky blackness of space. Suddenly, you spotted a region of pure nothingness, a perfect circle of black against the star-dusted velvet of the cosmos. It's a stellar mass black hole, maybe a few times the mass of our sun. Your curiosity gets the better of you, or maybe your ship's engines fail. Either way, you're on a one-way trip toward the event horizon. At first, you wouldn't feel much. A black hole's gravity is just like any other objects from a safe distance. You could orbit it, just like we orbit the sun, but you're not orbiting, you're falling in. As you get closer, things start to get strange. The first thing you'd notice is a gentle tidal force. The side of your body closer to the black hole is being pulled slightly stronger than the side farther away. For a supermassive black hole, like the one at the center of our galaxy, this tidal force is so gentle you might cross the event horizon without even realizing it. But we're dealing with a smaller stellar mass black hole, and for you, the experience will be much more dramatic. This stretching force grows exponentially as you approach. It's a process scientists have a rather grim name for: spaghettification. Imagine you're falling in feet first. Your feet are being pulled so much more forcefully than your head that your body is stretched out, thinner and thinner, like a piece of spaghetti. It's a gruesome thought, but physics is unforgiving. Your body, your ship, every atom you're made of would be drawn out into a long, thin stream of matter, funneling down into the abyss. But let's rewind a bit. Let's say you could somehow survive spaghettification. What would you see? This is where Einstein's theory of relativity really kicks into high gear. As you fall, time itself begins to warp. To an observer watching you from a safe distance, say your crewmate on the mothership, something bizarre happens. As you approach the event horizon, you would appear to slow down. Your movements would become agonizingly sluggish. The light from you would become redder and dimmer, a phenomenon known as gravitational redshift. You would seem to be frozen in time, hovering just at the edge of the black hole, fading slowly over an infinite amount of time until you disappear completely. Your crewmate would never actually see you cross the event horizon. From their perspective, your final moment is stretched out for eternity. But from your perspective, it's a completely different story. Time for you would feel normal. You'd see stars being born and dying, galaxies colliding, and maybe even the end of the universe itself. All in the few moments it takes you to cross the event horizon. The universe's clock is ticking at an infinitely faster rate than yours. Now, let's talk about the event horizon itself. It's not a physical barrier. You wouldn't crash into it. It's simply the point of no return. The point where the gravitational pull is so strong that the escape velocity exceeds the speed of light. Once you cross it, there's no going back. No message, no light, nothing can escape. You are now inside the black hole. What's it like inside? Well, nobody knows for sure. Our current laws of physics, both general relativity and quantum mechanics, break down here. It's a realm where our understanding of reality ceases to apply. Inside the event horizon, the roles of space and time are swapped. The direction down toward the center is no longer a direction in space, but a direction in time. It's the future, just as you can't stop moving into the future. You cannot stop moving toward the singularity. Every possible path, every direction you try to move, inevitably leads to the center. And what is the singularity? It's the very heart of the black hole, a point of supposedly infinite density and zero volume, where all the mass of the original star is crushed. According to general relativity, this is your final destination. What happens when your stream of spaghettified atoms reaches this point? The honest answer is, we don't know. Does it get crushed out of existence? Is it the gateway to another universe? Some theories propose wild ideas. One idea is that of a white hole, the theoretical opposite of a black hole. A white hole would be a region of space-time from which matter and light can only escape, not enter. Perhaps falling into a black hole means being spewed out of a white hole somewhere else in space-time, or even in another universe entirely. This forms the concept of a wormhole, a cosmic shortcut through space-time. However, most physicists believe that such a wormhole, if it could even exist, would be incredibly unstable and would collapse the instant you tried to pass through it, so probably not a viable travel option. Another fascinating idea comes from the holographic principle. This suggests that all the information about what falls into a black hole isn't destroyed at the singularity, but is instead encoded on the two-dimensional surface of the event horizon, like a hologram. So, in a way, a version of you, or at least, all the information that makes you you, would be smeared across the event horizon. This is a potential solution to the black hole information paradox, a major puzzle in physics which asks what happens to the information of the things a black hole consumes, since quantum mechanics says information can never be truly destroyed. Let's imagine you chose a different path and aimed for a supermassive black hole instead. Like Sagittarius A, the behemoth at the center of the Milky Way, this black hole is millions of times more massive than our Sun. Because of its immense size, the curvature of space-time at its event horizon is much gentler. Inside this colossal giant, you might have minutes, maybe even hours, before the tidal forces become strong enough to tear you apart. In this borrowed time, what would you see? Utter blackness. No light from the outside universe can penetrate the event horizon. You are utterly and completely alone in the dark. The only direction is forward, toward the inevitable crunch at the singularity. The laws of physics, as we know them, would still break down, and your ultimate fate would remain a mystery. One more mind-bending concept is the firewall paradox. Some physicists propose that the event horizon isn't a calm, empty space, but a raging inferno of high-energy particles, the firewall. According to this idea, the moment you touch the event horizon, you would be instantly incinerated by a wall of fire. This theory arose from attempts to reconcile the principles of general relativity with quantum mechanics. If the firewall theory is correct, then there's no spaghettification, no journey to the singularity, no glimpse of the universe's future, just instant annihilation at the edge. It's a controversial idea, and many physicists are working on alternative solutions, but it highlights just how little we truly understand about these cosmic monsters. So, to recap your terrifying journey, you fall toward the black hole, experiencing extreme tidal forces that stretch you into a stream of atoms. From the outside, you appear to freeze in time and fade away. From your perspective, you watch the universe's future flash before your eyes as you cross the event horizon. Once inside, you're in a region where space and time are warped, and your only destination is the central singularity. There, at a point of infinite density, you meet your end, an end that our current science cannot describe. Or, perhaps you're instantly vaporized by a firewall at the event horizon. The reality is, black holes represent the absolute limits of our knowledge. They are cosmic laboratories where the laws of physics are pushed to their breaking point. While we can theorize and calculate, the true experience of falling into one will likely remain one of the universe's greatest unanswered questions. It's a one-way trip, and no one can come back to tell the tale. The journey is a fascinating blend of horror and wonder, a reminder of how strange and magnificent our universe truly is. Thank you so much for joining me on this plunge into the unknown. What part of this cosmic journey did you find the most mind-blowing? Let me know in the comments below. And don't forget to like, subscribe, and hit that notification bell for more explorations into the mysteries of our universe. Thanks for watching, and see you in the next one.